Right, so very good evening to you, and welcome to one more video. The topic of day is the concept of scalar product. So if you have reached the chapter where you start doing work done, this is the right time to learn about scalar product. So I'll quickly jump to what is scalar product. So vectors not only get added, but they get multiplied also. So far you would have done vector addition, but vector also get multiplied. One of the very important multiplication of vectors, the concept is called as scalar product. Okay, it's popularly also called as dot product. So scalar product and dot product is a mathematical concept used in physics, and the dot product of two physical quantities, for example force and displacement, gives you the work. So let's understand what exactly is this technique all about, and how do we apply this to situations of work done. And I will use an example of work done because that is the easiest one and perhaps most relevant in this situation. So let's talk about dot product. So if you look into this, you have a force which is getting applied on a block, and this block, because of the force, moves through a distance of 2 meters, and this is 5 newtons and 30 degrees. All right. So let's understand what is the meaning of scalar product here. If you talk about scalar product in itself, the way you will articulate scalar product is, if you look into this, the displacement of 2 meters, and try to understand what it implies. So the body has moved through a displacement of 2 meters because of 5 newtons. 5 Newton can be resolved in two parts. The first part is the 5 cos 30, all right? And the second part is 5 sin 30. Now, as per the definition of scalar product, the force component, which is this, which is parallel to displacement, okay? See that displacement is in this direction, okay, which is x-axis, and the force is the component of the force which is along the displacement is the one that contributes to work done. So if you write work done is equal to F dot S, which is a vector way of writing the dot product, what you're actually doing is you're multiplying the x component of force with the displacement, which is also in the x-axis. This is an example of x-axis, but you could have any situation like this where the force is in this direction and the displacement also is in the same direction. You could apply, because these are parallel to each other, you could apply the situation. But conventionally, the typical definition is the force which is getting applied here is, just have a look at this clearly. You can see how it is looking, right? So that's the way you have to, so F cos theta, is the horizontal component. The displacement is also in horizontal. And this could be applied in any direction whatsoever. But these two should be, what matters in physics is the component of the second vector, which is B, for example, and this is A, right? So if you're doing A dot B, what you're actually doing is you are multiplying the component of A with B, which is parallel to B, okay? So A cos theta is parallel to B, like F cos theta is parallel to displacement. The perpendicular part, which is F sin theta, does no work. So the force component, which is perpendicular to the displacement, does no work because the angle between them is 90 degrees, okay? This is displacement. This is your force component, which is along y-axis. So just be very careful that when you have this situation, the component of the force is the one you take is in the same direction as displacement. That is what contributes to the situation of work done. This force will contribute nothing. So whenever you're given a force,